Today's lesson is on solving trig equations. First of all, you want to isolate the trig function and the variable. Second, you want to figure out the reference angle. Third, see if the ratio is positive or negative. That's what's on the other side of the equation. And lastly, figure out where the trig function has that sign, whether it's positive or negative, and then place it in that particular quadrant. Before I demonstrate that process for you, I want to teach you a little trick that my high school teacher taught me, and it's that all students take calculus. Of course, we know that's not true, but that's just a way to figure out the signs of the trig functions. The A stands for all, the S stands for the sine function, T stands for tangent, and C stands for cosine. So we put it in that order, quadrants 1, 2, 3, and 4. Now, what that means is if the terminal side of an angle falls in one of those categories, one of those quadrants, that determines the sign. For example, let's say the terminal side of an angle falls in quadrant 2. That's the sine quadrant. See, all students. So that's the S. That means if you got sine, cosine, tangent, and their reciprocals, if we fall in the sine quadrant, that means sine and its reciprocal are positive, and the other 4 signs would be negative. Okay? Let's do another example just to make sure everybody understands what I'm saying. So let me clear those signs. Let's say the terminal side falls here. All students take. So that's the tangent quadrant. So tangent's positive and cotangent's positive, and the other 4 are negative. But if you fall over here, this is the all. So everything's positive in the first quadrant if the terminal side falls there. So that's for all angles less than 90 degrees, between 0 and 90. So that's how the quadrants work, okay? Just want to make sure you understand, because we're going to need to understand the signs very well in order to solve trig equations. So, step 1, isolate. Well, it's already isolated, tangent theta. Next step is figure out the reference angle. So the first thing you would do is draw a triangle, throw theta in one of the corners, doesn't matter. And now I like to make it a ratio, so I just put it over 1 if it's not already a fraction. So tangent is opposite over adjacent. So opposite, I'm going to make radical 3, and adjacent, I'm going to make 1. And I recognize these numbers, 1, 2, radical 3. So my reference is across from the radical 3, so that's 60 degrees. Okay, so now the next step is to see if the ratio is positive or negative. It is indeed negative. So the question is, where is tangent negative? That is the big question. And so what I'm going to do is all students take calculus. Okay, tangent is positive here, and tangent is also positive in the first quadrant. So my tangent is going to be negative in the second and fourth quadrant. So what I'm going to do is I'm going to place a 60-degree reference angle in this quadrant because tangent's negative here. And I'm going to see what that angle is in standard position. That's 120 degrees. So that is one of my answers. Also, the fourth quadrant, I'm going to put a 60-degree reference. And remember, the reference is always connected to the x-axis, never the y. That's why I always stress that. And now in standard position, if I go all the way around, that would be a 300-degree angle. So I have two solutions. Theta equals 120 degrees, or it could equal 300 degrees. And if you wanted to double check your answer, you could punch in the tangent of 120 on your calculator, and you'll see the answer is negative radical 3. Or you could do the tangent of 300 on your calculator, and you will also get a negative radical 3. Okay, and these are all possible answers between 0 and 360 degrees. Now, someone might say, well, Miss Adams, couldn't I get tangent by itself by simply taking the inverse tangent of both sides? And I would say, absolutely. But the calculator is only going to give you one of the solutions. It's not going to give you both. Okay, so beware of the calculator. It is only going to give you calculation. It is only going to give you one of the solutions. And sometimes there's one solution, sometimes there's two, sometimes there's four. Actually, usually it's either no solution, two solutions, or four solutions. They generally come that way. Okay, so let's solve for theta in radians. I still like to think in degrees, and then when I finish, I'm going to convert back to radians. And this should say between 0 and 2 pi. When you're thinking in radians, you know, we want to do that. Now, I need to do step 1 and get sine theta by itself. So the first thing I'm going to do is subtract 3 from both sides. And I get the square root of 2 equals the secant of theta. And the angle is stuck to the trig function. Okay, and now I'm going to divide both sides by the square root of 2. So the secant of theta equals, I don't like the radical on the bottom. I better get that out of there. And so that's going to be 2 radical 2 over 2. Oh, cool. So this is just secant of theta equals the square root of 2. I like my ratio to look like a ratio, so I always like to drop it over 1. So now secant is hypotenuse over adjacent because it's the reciprocal of cosine. So now I'm going to make a triangle. Throw theta in a corner, doesn't matter. But now I have to follow the directions and make the hypotenuse radical 2 and the adjacent side 1. Oh, if I were to use Pythagorean's theorem, I could find the missing side, 1 radical 2, and that would definitely have a reference of 45 degrees. Okay, so at this point, I evaluate the signs and I say, where is secant positive? See, there's no negative sign there. This is positive. So all students take calculus. Secant goes with the cosine. So secant is going to be positive in the first and fourth quadrant. So I need a 45-degree reference angle in both of those quadrants. So my first answer in standard position is 45 degrees. Second answer, what is that? 360 minus 45 is 315. So I'm looking at 45 degrees and I'm looking at 315 degrees. But I have a little situation. The problem asks for radians. So we're going to convert, and hopefully you remember how to do your conversions. So one of my answers is pi over 4. And my other answer, if you do your math, pi over 180. And we're going to find that this is 7 pi over 4. So we have two solutions. Theta equals, I should have put that. Both of those will make this equation true. Okay, and you could definitely plug in and double check that. Example 3, we're going to solve in degrees. I'm going to add 4 to both sides. And I get 3 cotangent squared. Ooh, so that means the actual ratio is squared. I'm going to divide by 3. And so I get cotangent squared theta equals 1/3. I'm going to get the cotangent by itself, so I have to take the square root of both sides. Whenever you're doing a fraction, I definitely urge you to do the numerator and denominator separately. So now what I have is absolute value of the cotangent, and that's 1, and that's radical 3. And that means I'm going to get plus or minus when I remove those bars. Remember, whenever you take the square root of a square, you get plus or minus. And for ratios, we definitely have to acknowledge this. Now, in this situation, I don't want to rationalize the denominator. And the reason why is that I recognize the 1 and the radical 3 as being a part of a triangle. So this is adjacent over opposite, because that's cotangent. Or you could flip it. You could think of it as tangent theta equals plus or minus radical 3 over 1. You could do that. And notice the radical 3 is still the opposite and the 1 is still the adjacent. So no matter how you do that, you're going to get your radical 3 here and 1. Across from radical 3, we have our 60-degree reference angle. Now, where is tangent positive or negative? Well, all students take calculus, and we definitely see that if I put a 60-degree reference angle here, 60 reference here, 60 here, and remember it's always nestled against the x-axis, that gives me 60, theta equals 60 degrees. This one is 120. If I stop here, that's 180 and 60, gives me 240. And if I go all the way around here to that one, I get 300. So wow, we get 4 solutions. And if you plug 60 degrees in, and remember, this means that the ratio of that is squared, not the 60. The 60 is not squared. Okay, it's the ratio that's squared. Okay, and we'll talk a little bit more about how to check that. But if you wanted to, the way you would plug in cotangent squared theta, you would plug in, let's see, 1 over tangent 60, and then you would square that value like that. Okay, so that's how you would actually punch that part into the calculator. And of course, you need the rest of the equation. Alrighty, example 4. This is a quick one, but I definitely wanted to show you how to do this. Where does the cosine of theta equal 0? 0? How can adjacent over hypotenuse be 0? There's no way for an adjacent side to be 0. So now I'm not even thinking about a triangle anymore. What I'm thinking about now, I always like my ratios to be over 1, by the way. Now I'm thinking, oh, that must be on one of the axes. Okay? So now what I'm thinking is, what are the coordinates of each of these points? Well, that's 1, 0. That's 0, 1. Let's see if I go back 1 or if I go down 1. So cosine is x over r. So if I want to get 0, that means I need the x coordinate to equal 0. Where there's 1, x coordinate equals 0 here, and x coordinate equals 0 here. So I have two solutions, either 90 degrees or 270 degrees. It says between 0 and 2 pi in radians. So instead of saying 90 degrees and 270 degrees, I'm going to convert. And so I have two solutions, pi over 2 and 3 pi over 2. So those are my two solutions. Alrighty, example last. Solve for theta in degrees and round to the nearest tenth. This is going to be a little trickier. Round to the nearest tenth. I can automatically see this is not going to have a reference of 45, 30, 60. It's not on the axis. So it's not going to be any of that. So for sure, we're going to need a calculator. The first thing I would do, since I'm going to need a calculator, is change this to sine. I can just do the reciprocal since I have a fraction. Okay, so notice I just tossed that upside down. And now I'm going to take the inverse sine of both sides. So this side cancels and I get theta equals the inverse cosine of 5/8. Now, when I punch this into the calculator, it asks for the nearest tenth. So I get 38.7 degrees. That's only giving me a reference angle. That is not the sole answer. This is the reference angle. Now, I still have to say, where is cosecant positive? All students take calculus. Well, cosecant is the reciprocal of the sine, so it's going to be positive here and, of course, positive here. So I'm going to put a 38.7 degree reference angle in both of these quadrants. And so one of my answers is indeed 38.7. But for the other one, I'm going to subtract from 180. And that's going to give me 141.3 degrees. So 180 minus 38.7 is how I got the 141.3. So those are my two solutions. Oh, wait a minute. Yeah, in degrees.